Hi, welcome back to the Fenton Weill amp, and I've got it in a position now to power it on. In fact, it is switched on, sorry. And I brought it carefully up with the variac. There's no output from it, but it is behaving. Our voltages are good. Our main HT line is 300 volts, 308 volts, and we've got all the other supplies going to the various parts of the preamp, but there's no output, although the output stage is working and the driver stage is working. I can prove that by getting hum from the input to the driver valve. So I would say the fault's in the first stage, in the EF86 stage. We can see if it's got its supply on its anode, which I believe is pin 6. This one, could make a good connection with the meter. We've got 194 volts on its anode, and you can hear the hum, which tells you that the rest of the amp's working okay. Its supply resistor on the supply side is also 194 volts, so that tells me the valve's not drawing any current. Now I can see what's on its cathode. There should be a couple of volts. And looking at the meter now, there's 0 volts on its cathode, so the valve's not doing anything. So let's switch it off and try a valve. Switch it off at the mains. Oh, and looking at the valve, it's got yeah, it's failed. It's got air in the vacuums gone in the valve. You see that white, cloudy, milky white effect. That tells you that the vacuum's failed. In fact, the valve's cracked at the bottom, so it's no good. So let me just grab another EF86. You've got a nice GEC vintage EF86. We'll put him in. Switch on. It's warming up. It's doing things now. I don't know if the mic's picking the hiss up. Tremendous amount of hiss. And on the cathode, we've now got 3 volts, so the valve is conducting. On its anode, we should have volts drop across its anode load. 120 volts, 173 volts going in. So let's see if this is dependent on the volume controls. No, it's not. It's there all the time. Or the tone controls. No, there all the time. I would suspect the hiss is caused by this cathode decoupling capacitor. Let me just grab a capacitor. Now there's only 3 volts on that capacitor. We can temporarily clip one over it, and let's listen to the hiss, see if it improves. There, the hiss has gone. So this capacitor wants replacing. Let's give it some input from the signal generator. I would think that the amp is working. Let's see. The generator's set very low. Let me increase the frequency. Okay, the amp sounds. Let's switch it off. Just go over a few things. Okay, that sounded pretty good actually. It needs this capacitor replacing, this one. We'll go over all the resistors and the rest of the caps, but I did notice that the tone controls are not working, and I'm pretty sure that'll be caused by these 2 capacitors, which will have failed. These are the waxy paper ones. These are terrible caps. So in the next video we'll have replaced these, gone round all the resistors, caps, and replaced these 2 capacitors. So I hope that's of interest. We should have a fully working amp on the next video. For now, thanks for watching.